Okay, Algebra 1 fans, our topic for today is factoring. And this is going to be quite a few sections because we're going to go through a lot of the different types of factoring. If you look at the objectives, you see a lot of different things. Factor out the greatest common factor, factor trinomials with lead coefficient equal to 1, greater than 1, special patterns, and completely factor. So before we start, let me tell you your joke of the day. How many tickles does it take to make an octopus laugh? And the answer is tentacles. 10 tickles, tentacles. There you go. All right, we're going to start with the most basic kind of factoring, which is called factoring the greatest common factor, or GCF. Now, some of the vocabulary, remember that when you multiply two numbers, 2 times 4, you get 8. What you get is called the product. But the two numbers that you're multiplying, those are called the factors. So what you get from multiplication is the product, but the actual numbers that you're multiplying are the factors. You can also think of it as the factors divide into the product. Okay, so the factors, they divide into the product, whatever that value is. Now, even if we have variables here, so directions, factor out the greatest common factor, GCF, of the following polynomials. So if we have 3x minus 9, what we're thinking is there a number that divides into both of these? Is there a factor of 3x and a factor of 9? Because what we're going to do is we're going to pull that outside of parentheses. Okay, because I'm going to give you another example here. Let's go back to distributive property. Let's say we had 5 times 2x minus 3. Well, distributing means to multiply. And you would do 5 times 2x and you would get 10x. You would do 5 times negative 3 and you would get minus 15. So if distributing is to multiply, factoring is to reverse the process. Factoring is to go from here back to this. So we end up with 3x minus 9. That's after distributing. So what was the number that would have been on the outside? Well, you can look at this and say, okay, 3 divides into 3x and it divides into 9. So we're going to take a 3, we're going to pull it outside parentheses. And then what I like to do is I'll just put both of these terms over 3. So I'm going to divide them. 3 divided by 3, we get 1x. Negative 9 divided by 3 is minus 3. And that's it. So the number 3 that we pulled out is our GCF. And then what we would be left with is 1x minus 3. Now you can always check, because if you distribute this, you should go right back to where you started. 3 times x is 3x. 3 times negative 3 is minus 9. All right, look at the second example. 10a squared minus 25a. We're always going to pull out the greatest common factor, the biggest factor we can find. So if you look at 10 and you look at 25, well, a number that divides into both of those is 5. But then if you look at the variables, you have a squared and you have a to the first. Both of these can be divided by a. So I'm going to put an a with the 5. I'm going to pull both of those out. Now, to figure out what's left over, let's divide here by 5a and divide here by 5a. 10 divided by 5 is 2. A squared divided by a to the first, you can subtract the exponents and you get a to the first. Negative 25 divided by 5 is minus 5. A divided by a is 1. Okay, so the a's will totally reduce out, so there's no more a. So we have 5a times parentheses, 2a minus 5. We are pulling out the common factors. So the 5a is the GCF again. And that's it, you're done. You know that you're good if you look at what's left in the parentheses and the only thing that would divide into both of these would be a 1. That's how you know you're finished, because this is completely factored now. You may have asked, well, why couldn't we divide out a squared? Why couldn't we factor out a squared? And the problem is, if I took the second term here, the minus 25a, and tried to divide by a squared, well, the problem is, this is only a to the first. So I don't have a squared that I can pull out of this, and I have to be able to pull out the same amount from both of my terms, from all of my terms. So this a squared would be too big. So we can't do that. The most we can take out is a to the first. All right, let's try number 3. I like to look at the coefficients first, 16 and 12, the numbers in front. Both of those are divisible by 4. Now we have m to the third and m raised to the first. The most we can take out of both of those is m to the first. Okay, so you can look at this and say, whatever the smallest exponent is for that variable, that's the most you're allowed to factor out. And then you have n to the second, n to the second. Well, since both of those have n to the second, let's factor that out. So here's our greatest common factor. Now I'll open parentheses. Now we need to find out what is left. So let's take both expressions here. We're going to divide by 4m n to the second, 4m n to the second. Notice I put m to the first for these. You don't need to, but I like to remind myself that the exponent's a 1. 16 divided by 4 is 4. M raised to the third divided by m raised to the first. If you subtract that, you get m to the second. N squared divided by itself is 1, so that's going to go. Plus 12 divided by 4 is 3. M divided by itself is 1, so that reduces out. N squared divided by n squared is 1. Here's our answer. Again, if you're not sure, we can always distribute and see if we get the original problem. 4 times 4 is 16. M to the first times m to the second is m to the third, and then n squared, plus 4 times 3 is 12, m to the first, n to the second. Number 4, now we have 3 terms. Look at the coefficients, 4, 12, 36. Those are all divisible by 4. Now if you look at the variables, x to the third, x to the second, x to the first, the most we can take out is x to the first. We have to be able to factor out of each term. So we take out x to the first, open parentheses. To find what's left, okay, we're dividing this out, 4x. Now this will be 1, and this will be x to the second. Minus 12 divided by 4 is minus 3. X to the second divided by x to the first is just x to the first. 36 divided by 4 is 9. X to the first divided by itself is 1. And that's all you can do. Now, in number 5, you have 4 terms, and I'm going to show you a new method here. It's called factor by grouping. Since we have 4 terms, we're going to pair these up. Here's the first pair, a squared minus 4ac. I'm going to underline that. And then the second pair, I'm going to underline that twice. Now what we'll do is we'll look at the first pair and we'll pull out that GCF. Both of these have a. So we pull the a outside parentheses. If we divide by a, this would become a to the first minus 4. The a's would reduce, so it would be minus 4c. That's what's left. Now in the second pair of terms, both of these have b. So I'll take out positive b. Now let's see what's left. If we divide out b, this would just be a, because these reduce, and this would be minus 4c. Okay, now what you may notice is that the first group and the second group have another common factor. Now this is a binomial. Binomial just means two terms. Binomial means two terms, but it's the same binomial. So in this first pair, they both had a as a common factor, so we pulled that out. But now, both of these expressions have another common factor. It's a minus 4c. So we will pull that out. So I'm going to take that out of this expression and this. Now, if I take that out, what would be left in this expression? It would just be a. And if I factor out a minus 4c in this expression, what's left is b. So we end up with a minus 4c times a plus b. And that is factored. Okay, and in the last one here, let's see, let's pair up the first two. What goes into 24 and 54? Actually, 6 does. And then notice they both have an a. So we'll factor out 6a. Now, you don't need to always write down the GCF, what you're dividing by. So let's say if we divide by 6, we would get 4. A divided by a reduces, so 4b plus 54a divided by 6a is just 9. In the second pair, notice that both of these are negative. 20 and 45 are both divisible by 5, so I'm going to factor out minus 5 from these. Now, if I divide this by minus 5, we get positive 4b. Negative 45 divided by negative 5 is positive 9. Now again, notice that both expressions have the same factor still. They both have 4b plus 9. So our last move is we need to factor out that common factor. So we pull 4b plus 9 out of parentheses, and then what's left? 6a minus 5. And that is the end of part 1.